Hello everyone. Is my camera flickering? What the fuck? It's working perfectly fine for like an hour. What the hell? I'll unplug and plug it back in. Yeah, it's glitching. What the fuck? How's that? Is that better? I just unplugged it and plugged it back. I flipped the USB Type-C over. So I'm using my nice camera today because the video quality of the last stream was not great. Downside of the nice camera is the nice camera is picky and doesn't have built-in LUTs. So I'm using color correction in OBS. Hopefully that looks decent. It also doesn't support USB 2, so I had to dig out a USB 3 Type-C cable. And that cable is giving me trouble, apparently. But hopefully it looks better. I have myself open on too many windows. I should stop that. Stop that. Yeah, so welcome everyone. Today we're talking about a magical and misunderstood protocol, multi-protocol label switching, or it's about this word, I'm backwards. MPLS. So MPLS has been around for at least 25 years. Let me take a quick look on Wikipedia to see when it was released. I'm guessing it's late 90s. MPLS, multi-protocol label switching. Cisco Systems introduced a protocol called Tag Switching and Tag Distribution Protocol. This was turned into Label Switching and Label Distribution Protocol, 1997. So, coming up on 30 years old now, I guess, for MPLS. It's a little dreary. Yeah, I think that's because I don't have great color correction for live. I usually do LUTs with this camera in post, do color correction there, but I don't have that applied right now for live because I do it in post usually. I tried to tweak it a bit, but it's what I got. It's also legitimately quite dark here in Finland. I got all the lights on, but yeah. So MPLS was designed to run over ATM originally, and it was massively popular for that. Now it can run over Ethernet as well, and it has some cool advantages in that the inner protocol can be anything, and the MPLS header is really small. And based on this MPLS header, we can build out a whole bunch of different routing technologies that are really efficient to implement on the routers, don't require the router to know all the protocols they're routing, and those are some of the advantages. So I'm going to show in diagram form some of the use cases of MPLS. So I got Coke, by the way, from the that glass, and water. So let's flip over to, come on, you're doing this to me too. It's supposed to be the window capture. What happened to you? Come on. Come on. Do it. There we go. Okay, we're back. So here in the diagram, we'll turn that off. That's the wrong mouse. I've got a mouse here for the streaming computer and a mouse for the laptop. Actually, I can just switch this over to the laptop and then I don't have to deal with it anymore. So, imagine I got some routers here. We'll call them R1, R2, R3, R4, and R5. And we'll connect them all up using diagonal lines. So we'll do that. So this might be what your network looks like. I don't know how many of you guys have a network that looks like this. Most of you probably don't have a network with more than one router, but if you did, you can end up with things like this. So we'll say R1, R1, R2, R3, R4, and R5. So I don't know how this looks to you guys. So this has now created a loop. So how we break this loop is one of the fundamental questions of networking, I guess. So one option we have is spanning tree. So spanning tree will look at this. And if you don't configure spanning tree, you just let it be random. It will pick one of these links at random and delete it. So now you don't have a loop. There's no problem. But what if someone on R4 wants to talk to R1? Now they got to go all the way around this loop. It's inefficient. But we've guaranteed to have something that won't cause problems. So spanning tree should not really be used as a design element. It should be like a last resort. So put that link back. So now if we make these all routed. Now each of these routers needs a full copy of our routing table, which sounds great, right? But imagine that this guy here is an edge router for transit. And then, oops, stop. And then this guy is an edge router at a IXP. So we're taking in, I don't know, thousands of routes from the IXP. We're taking in 1 million routes from our transit. And these guys here, maybe these are where our customers are. So customer, and more customers, they're off these routers. Oops. So now, suddenly, these routers here need to store 1 million routes in their routing table. And that looks kind of scary, right? But what if, in addition to that, our customers are also giving us routes, and our customers want their own routing tables to send their own routes between their own locations, and this spirals into each of these routers suddenly needing really, really, really big routing tables. So, what MPLS does, in its most basic form, we assign each of these routers a number, and I already gave them a number, so I have R1, R2, R3, R4, R5, and at where the packet comes in, we label it with its destination and route it based on that. So I have a packet. Where's a packet? Here's a packet. So our packet's pink. So we're going to, well, I don't know. So it comes in from transit, and it needs to go out to a customer. And this router has the full routing table. So it looks up where the destination of this packet is all the way through the network and says it needs to go to R3. So we add a label on top that says R3. Then this router here at R2 doesn't need the whole routing table. All it needs to know is how to get to R3, and it can pass it on to R3. Now once we get to R3, we pop the header off, the MPLS header, and now we have the inner packet. So it doesn't need the full routing table, but it needs enough routing table to get to this destination locally. So that means the R3 router probably needs like a default route and a couple other routes and stuff like that for its locally connected stuff, and everything else it can rely on labeling it to one of these other routers. So we can essentially rely on our edge routers to be adding these labels, and then our core routers in the middle just have to have label routes, which is much more efficient. I'm going to check on the chat now real quick. So you guys have been chatting a lot. Need to get a gray card. Yeah, probably. Cisco, OSPF. So OSPF has a different problem, which I will get to. So OSPF and areas. So the other advantage of MPLS is in traffic engineering. So if I flip back to this guy now. So imagine hypothetically, this link is 25 gig. This link is 25 gig. This link is 10 gig. 10 gig, 10 gig. Oops, hide that. And this one's 10 gig. So if we take the inverse of the link speed as our link cost, we might say 25 gig has a link cost of 4, because that's like 100 over 4, and 10 gig has a link cost of 10. So going from R1 to R5 via these two 25 gigs will give us a total cost of 8. And going via these 10 gigs, 10, 10, and 10 would have a total cost of 30. Right? So in OSPF, it would always prefer to route via R4 instead of via R2 and R3. Now what if we flip this around? So these guys are 10 gig, which means their cost is 10. And these guys are now 25 gig, so their cost is 4. And same with this one, 25 gig. And this one also 25 gig. And this one also 25 gig, or 10 gig. So now our top path has a cost of 20. And our bottom path has a cost of 4, 4, and 4, which is 12. So now OSPF is going to prefer the bottom path. And you say, well, that sounds great, doesn't it? But 10 gig is not that, I mean, it's slower than 25 gig. But now we're taking an extra hop instead of a slightly slower path. And if we have a lot of customers off of R2 and R3 and not a lot off of R4, we could end up where this path and this path is very underutilized because OSPF is strictly taking the best path and not multiple paths. So one other approach is we could use MPLS to steer traffic to take a specific path instead of whatever path it wants. And so that is called MPLS traffic engineering. And that works by essentially forcing certain routers to be part of the path. So here when we come into R1, we could say we want to egress via R5, but then we can add another label on top of that, which says we want to egress via R4. So we send our packet out to R4. R4 looks at it and it's like, ah, I'm R4. Pop that label off the stack. Now it sees another label underneath that says R5, so it says I'm R5. R5 pops the label and it gets the original packet. Oops, I don't have an original packet, but you get the idea. So by using MPLS, we can force traffic to take a specific path and not the best path. And so if you have networks where you have a lot of paths like this, it's possible that instead of upgrading these guys from 25 gig to 100 gig, it might be more effective to start steering traffic on underutilized paths. Especially in the case of really big service provider networks, where this might be a city and this might be two other cities, and you want to send some traffic through this router to offload these two routers in these cities, and your network is based on the geographic realities of connecting different cities together, and not the ideal data center networks, which are often very idealized. They have very complicated flow fabrics that are very symmetrical, and they can reliably use 16-way equal cost multipath because they've designed all of that in when they design the data center. If you design a physical network in the real world that's not in a data center, you can't always do that. So MPLS also lets you steer traffic. So back to comments. Someone said, there's a fish species named Cisco. Spanning tree is the root of all evil. It definitely is. Do not do spanning tree on a large scale. Generally, you should have it enabled so that if you do make a loop, it breaks it. But you shouldn't be relying on spanning tree day to day. OSPF in areas. Hop count versus cost of the path. So in old routing protocols like RIP, yeah, so in RIP, we strictly cared about hop counts. We would always take the top path because it has one less hop. In OSPF, we care about the total cost. So each link segment has a cost, and we add up all the costs as we go, and we take the total route that has the lowest cost. So we can manipulate the cost, but only for the whole link, not for a specific route across that link. Now another option you have is use BGP, and so BGP lets you apply policy per route, but it doesn't let you choose the path that traffic will take if you're doing it internally, iBGP. Now you also have the option of doing eBGP with local or reserved AS numbers. So some hyperscalers do that, where every single node is its own AS, and so it's doing its own AS path. Then you can use BGP policies on every single node to steer traffic individually. But that is a lot of management overhead, to be honest. Someone says, R1 gets to write an itinerary. Yeah, so that's called segment routing. That's sort of like the final evolution of MPLS. There's also segment routing v6 in IPv6, which I also think is really cool, but has the downside of much bigger headers. So MPLS headers are only 4 bytes, and each label adds another 4-byte header, so it's not very big, even if you have quite a few of them. Whereas in segment routing v6, each label is it's either a whole other IP header, or it's another routing header within the IP header. So you have a 40-byte IP header. If you're carrying traffic that's not IPv6, you need that entire 40-byte IPv6 header to add on top for segment routing. And then you need a stack of additional segment routes for each step of the way. And those have a 128-bit address, which means that the segment routing headers can be massive. So MPLS is much more pragmatic, small. That's what I like about it. So let's get to setting it up. So I should probably make a new tab. I have a Mikrotik here that we can use to test with. It's a hEX-S. I also have a HAP-S if we want to test with a newer one. I have the newer version of this that has Wi-Fi. And then I've also got a CRS-305, which can do MPLS also. And I've got Linux. So I'm going to start out with a Linux virtual machine. I think I need a virtual machine and not a container, but I guess we could try a container too. Let me read my own thoughts. Pre-setup, VMs. Yeah, okay. So I guess my pre-setup is going to be creating a VM. We'll use the CRS-305 as the next hop, and then I'll use this as my last hop, and I'll plug my laptop into this. How does that sound? Let's create a new window. Okay, once I get all my private stuff out of the way, then I can switch over to you. Hi. Nope. Hold on. Okay. No password for you guys. Do I have any VMs that I've been laying around? I have SR-test. I could use SR-test. One of the problems I encountered was that I needed the full kernel. I guess let's just try doing this in a container and see what we get. Kind of wish I had a third monitor for my chat. I guess I could put my chat on the phone. Let's see. Can I open chat in here? The YouTube Studio app is kind of awful, by the way, in case you're wondering. So I think I need YouTube app. Got an ad watching my own chat. F off. Come on. Come on. I just want the chat. I just want the chat. Stop it. Stop it. Come on. Okay. Yeah, so someone mentioned that MPLS work good on low power routers. That is also true. So you could have a lot less space. If you allocated your labels well, so if I go back to the drawing here, since these numbers are 1, 2, 3, 4, and 5, they're not like IP addresses where they could span a 32-bit range. We can decide as network admins what our MPLS addresses are. And so if you only had 1,000 addresses on your network, you could use 1 kilobyte of RAM and just put them straight sequentially. And that could be extremely fast on routers to do a lookup in SRAM instead of needing TCAM, which was another reason that MPLS was super popular, because you didn't need TCAM in the routers, so you could just use SRAM. Okay, so we're going to try the one I just started. I wrote some notes to myself. Where did I write them? Somewhere. Not that one. Okay, so I had to mod probe MPLS, then I had to syscontrol the number of labels I had. So let's see if that works. Okay. Yeah, so now I have proxysnet MPLS, and I now have that whole section of the kernel enabled. So that's cool. So now I can add a route, and I think I had that in my thoughts as well. Okay, so I have an address. So IP-F MPLS route add. Actually, no, I need the NCAP route first. This one, route IP-6. Say 2001 DB8 32 NCAP MPLS 1001 via. This one has to be reachable. I figured that out before. What's a good address? I'm going to duplicate this tab. Shut up, Safari. U. FD69. Okay. So now I have a route to 2001 DB8 via MPLS. So now if I try to ping, I get nothing. But if I TC dump it, TCP dump, and I should be able to do that in Wireshark, we can take a look at what the packet looks like. Switch back here so you don't see my whole desktop. Come on, Wireshark. What are you waiting on? Shut up. SSH dump, we're going to capture from there. try to run sudo. Use sudo. Okay, don't use sudo. Okay, so we got Wireshark, and it's doing stuff. So I filter for MPLS, and then I go over here and ping. And I should start seeing pings come in. There we go. So these should have an MPLS header. And if we take a look at them, we can see we've got, so this is the frame on the wire, and then we've got Ethernet 2, source MAC address, destination MAC address, and the ether type is 8847, MPLS label switch packet. Then we have multi-protocol label switching, which we look down here is only 4 bytes, 003E9140, so it's really tiny. And this says the label is 1001. Those bits are all 0. It is the bottom of the label stack, so normal labels, and it has a TTL of 64. And then within there, we have an IPv6 header, which has a source and destination, and Internet Control Message Protocol, that's our ping. So I guess we've got an MPLS packet sent, but obviously we are not really routing here. I've just shown how to send the packet. So now I need to set up one of my MikroTiks to act as a router. So what was I thinking about doing for that? Go back to my ideas. So I want to set up static labels. Okay. So now I need to pop that label to send it to like my PC or something. So let's set up the hex now, which means I need a power adapter. Plug the hex in. How are you guys doing in the live chat? Not very entertaining right now. We'll plug this in. Let's see. Okay, so this is booting up. So I need Winbox. Come to me, Winbox. Not the 305. What have you done? Winbox. What phone am I using? This is just a iPhone 14. I've had it for a few years and it works well for me. Okay, so you're supposed to be... Oh, I'm not plugged into my laptop. I wonder why. Okay, so... you should show up now, hopefully. You. I think I have no password. I don't remember the password. Admin. Hello. Someone said the hEX-S is a powerful router. Yeah, this can do MPLS too, which is what we're going to do with it. Maybe a new strategy. Maybe we do it on the this one. I will have to figure out how to log into the hEX eventually, but that is not today. That is today. That's in like, probably should just figure it out. New inbox. Really thought I didn't have a password. Well, I've messed that up. I guess I'll factory reset it. Reset. I think I go until the SFP light starts blinking or something like that. I factory reset this thing so many times. Okay, I'll let you sit there. Where's my fiber nick? Okay, so I got my fiber neck because it's easier to connect fiber. So we'll do fiber to the laptop right now, and we'll add the other router later. Okay, so now my network setup is, I guess we'll go over to the diagram. So we have, what do we call this test? MPLS 1. And we have none of these. Laptop, this is going to be SW4. This is 10 gig, this is 10 gig. How did you end up doing dumb things? So this one's going to be MPLS. This one's going to be IPv6. So that's what we're going to try setting up now. So this is going to send an MPLS route here, which is going to forward on to this guy. So in Winbox, this Winbox, I already have a bunch of VLANs I use for testing. I guess I'll just use one of those. Makes sense. So I guess that is, do I even need to? I guess we'll see. So do we have an IP address right now? So IP address, yeah, sorry. So I guess we'll use the IPTV LAN. Haven't used that one in a while, but oh, we do have an address, 9. Okay. So we're going to say 2001 db8:/64 on interface the IPTV LAN. I'll use customer com. Okay, so now 2001 db8 is available. Let's see if that shows up here. On EN20. Oh, I need to change the VLAN this guy's on. So interfaces. I'm on SFP plus 3, I think. Yeah, 3. So I'll change 3 to be on VLAN That's not here, that's under bridges. Bridge ports SFP +3 on VLAN 20. And just for good measure, I'll unplug the Mac and plug it back in. And then it should come up. Say forwarding. Please come up. There we go. So now you should get an address advertised by my router, which should be a 2001 DB8 address. Let's see. It's VLAN custom com. Oh, you can't see my screen. Yeah, you're right. Okay. So I now have 2001 DB864 on custom com, which should be VLAN 20, I think. I guess I can look. Custom com is VLAN 20 on the bridge. Okay. That's good. So do you have an address yet? No. Why not? To change the ND, IPv6 ND, should be valid. Okay, what if I Wireshark myself? Okay, new Wireshark. Close Wireshark. New Wireshark. And I want to capture on EN20, I think. Thunderbolt, that one. Okay, we're getting router advertisements. Oh, it's coming in tagged. Okay, that's our problem. So macOS does support VLAN tagging, but I don't want to do that in this case. I want to do it properly. So you are supposed to be untagged. Okay. Let's see what that did to our Wireshark. Okay, now we have all kinds of stuff going on. Yeah, 2001 DB8, we got an address. I should make it not default gateway eligible. Let's see, how do I do that? IPv6, ND interfaces. I can't set it to none. Oh well, I guess if nothing's broken, it's fine to have it sending this way. Okay, so now that is my route. So now I'm going to do the same on the other side. I'm going to create a fake subnet. I'm going to 2001 DB8 colon, what are we going to call this one? This one. Okay, so now you've got a route to 6.7. So we're going to delete this route. Okay, so now I need to add an NCAP MPLS via my, so we'll say 1001 is the outgoing, and it's going to be /64 NCAP MPLS via oops, stop it. Okay, we're going to close Wireshark because it has very irritating behavior. So this, what is this address? ::9. How did you know it was a 4.4? The DHCP client? Supposed to accept VLAN LAN. We'll take this one instead. So FE80. Okay, so that one should be sending now. So that's the sending route. So now if I go back here and I run torch, and I look for, I think it's going to come in, which one is it going to come in on? Two. It's going to come in on 2. MAC protocol is going to be MPLS. Why are you not an option? Whatever. We'll just start torch anyway. What did I say the MPLS ether type was? Whatever. So we'll ping that guy. And now we should see MPLS in torch here. What was the ether type? Okay, comment section looks good. Ether type, where's the ether type values? (8847). Why did you pick 802.2? Okay, so we're getting data here. 8847. It is not very much, but if I zoom back in, you can see we're getting a small number of packets. If I extend this out to a minute, I think we'll see more packets come in. Yeah. So it's receiving packets, just not very many of them. Which makes sense because we're sending pings. So now I need this guy to decap. So I'm going to do MPLS, MPLS. I believe this is a local mapping. Label is 1001. So now this guy should be processing this MPLS label, I think. I don't know. I guess we'll see. So if I come over here, Wireshark, and again on EN20, No pings are being received. Oh, because I'm not using the right address. I need to use this address as the destination of my ping. Still just router advertisements. So what if we switch you to be SFP plus 3? Do we have anything going on here? MPLS, PLS. Inactive. Oh, I need to add an interface here. SFP plus 2. Probably should read the docs on this a bit. Probably should open the comments because I bet people are already correcting me in the comments. MPLS interface, input equals yes. Okay. Definitely want that one. MPLS interfaces, input yes. MPLS forwarding table. Let's take a look at that. Nothing. Okay. MPLS reference, probably what I want. Oh, it's empty. Great. Okay, so my options here are accept filter, add, interface, local mapping, remote mapping. For some reason I thought local mapping is what I need to do. What if we do remote mapping? Still no pings coming in. Local mapping was showing inactive. Okay, so why is local mapping showing inactive is the question. Neighbor. Is this LDP neighbors? Okay, LDP neighbor. I'm not doing LDP. So label 1002. It's going to be whatever your IP address is. Which is going to be this guy. And we'll try this one. Doesn't like that. Okay, we'll try the global address. Okay, so that's how do we get to 1002? Local mapping. You guys are both I. Why are you I? Is it not turned on? Settings. Dynamic label range. there like a global MPLS disable that I'm missing? It should be in the forwarding table. So why is it not making its way to the forwarding table? So I have instance. Guess we could just make a blank instance. That did nothing. I thought that all I had to do here was add a interface for the mappings to work. But neither one of them are making their way to the forwarding table. So we do MPLS mangle, MPLS LDP. See, is MPLS one of these? No, I don't think so. Okay, so it requires that I create LDP even if I don't want to use LDP. It seems to be what's going on. Transport address. What is your address? Make a new one just for this purpose. We'll use that one. What else did someone in the comments section say I needed? ID and transport. LSR ID. Okay. Yeah, so I was trying to set this up as a static route, which just should need a local mapping. They're still being ignored. So you're still not making your way to my forwarding table. What I'm hoping is to just use the mappings, local and remote mappings, to set up just a basic tunnel. You're still inactive. Why are you inactive? Why are my static routes still not being handled? MPLS versus SD-WAN. I could do that. I think when most people think of MPLS, though, they're not thinking in that context with SD-WAN. They're not thinking of actually implementing MPLS themselves. They're thinking of buying an MPLS circuit, which means that someone else is doing the MPLS. Okay, back to the docs. So we'll do this via :9. See if that helps anything. So why are you still stuck at inactive? Look at the docs in the LDP section. LDP. Okay. So I need IP connectivity. I have that. I have... So I add loopback addresses. They add OSPF. They then add AFI's IP LSR, ID, transport address. So this is adding 2 interfaces to LDP. This is adding 2 interfaces to LDP. Okay. Can I do static neighbor mapping? Yes. Oh, I got a drink. What did I get? Peaceful pear. Okay. So what if I put you in as a static neighbor? So you're inactive also. Why are you guys stuck at inactive? Oh, my pings are getting through. Some of them did. For a little while. Interesting. So for a period of time, it was working. So we're at 9:30. So something I did made them get through occasionally. Oh, I think they've been working this whole time, even though they're inactive. So I go back and I delete this, the LDP instance and the LDP neighbor in the LDP interface. I think this destination unreachable is just getting cached somewhere. So we are now at, I don't know what time we're at now, but let's see if we stop the ping and restart the ping. Do we get a little burst? Yeah, we do. Okay. Might need 4 to 6 monitors. Yeah, that would be nice, wouldn't it? Actually, so it's saying it can't reach. That's different. Okay, so it's a DNS request that's getting queried. That is not my ping. No pings have made it through. I'm expecting one of these to come back once the ping works. Okay. Should we ask ChatGPT? What do you guys think? I'm going to switch over to my comment section. See what your opinion is. Greetings from South Africa, yes. I don't know. I don't trust ChatGPT, but I'm kind of out of options, so I guess we'll ask it. Yeah, fuck off. Okay, we're going to ask it. MPLS set enabled is yes. Is that literally something that is possible? Or is ChatGPT just pulling it out of its ass? Okay, print is not a command in this. Neither is set. You seem to be pretty good. So it's adding LDP, then it's adding an interface, and it's adding LDP on the interface, and then it's adding a local label. I think it's under LDP. Local mapping. Okay, so it has no idea what it's doing. Okay, I'm guessing that it's based on RouterOS 6. Filter by echo request and reply. Yeah, okay. I see IPv6. Okay, we have done that. I'd also like to point out that I don't actually pay for any AIs, so I'm limited to only free ones. Local bindings, remote bindings. Okay, local mapping. We're getting there, I guess. I could just do LDP. Oh, they offer MPLS. Let's see. Someone else has done this in 2019. For static LDP bindings to work, you also need static routes in routing table. Local bindings print. Okay, let's try that. Local mapping, it wants a dist address, which we're going to do. You're still inactive. And remote mapping, we're going to say 2001 DB867. You're also still inactive. Well, I guess that makes sense. Sources, okay, so I need a static route also. Let's see, IPv6 routes. Now we have a route. Are you still inactive? Yes. We already have a route for you because you're local. Okay, I was trying to set up a static route as like the first thing because I thought it would be easier, but I guess it is not easier. So we should just go straight into LDP. So the docs for LDP are not that great either, but I guess we'll try it. Okay, so first we are using loopbacks. I need OSPF, and then I need LDP. So we'll go here. Can you actually apt update without... Okay, I guess you can. Let's see if your package name is FR or not. I'll let that install and see if I got any comments. Okay, so seems like the whole static label thing is not easy to do in RouterOS. It's really easy to do on Linux. So Linux IP commands are awesome. So now we have FRR installed, and I'll come back over here. For our daemons, we need OSPF 6. And we need LDP. Yes. That should be enough. What is the OSPF 6 config for FRR? Do you have an example for me? Okay. Okay, I'll try this. He's 0, area 0, router ID. 0.0.0.1, area 0 range. What is area 0 range? Summary. Okay, we're not going to do that. Let's see, is this good enough? So we have no neighbors. Okay, makes sense. So we need to make neighbors. Routing, OSPF, new instance, version 3. Go. Area 0. Interfaces, interface templates. Type broadcast. Interfaces. SFP plus 2. Yeah, okay. Neighbors. If you come up, interfaces. Oh, you're not coming up on SFP plus 2. Oh, you need to come up on VLAN LAN. Okay, you're up. You're kind of up. You're trying your best. Are you on the same network? Yes. That is quite a router ID, but that works, I guess. I don't really care what your router ID is. Is this where I picked the router ID? Router ID. 0.0.0.9. There we go. See if you have changed your mind yet. Yeah, still that one or whatever. Comments. Yeah, so I think Mikrotik's docs have improved a lot for the things that people use day to day. So like usually when I do like routing or BGP or stuff, I found that their docs are really quite good. Wireless too, I really liked the docs for. MPLS, not so much. Okay, so you still have your old ID, but whatever. So now that came up. So now we have, oh, I need a loopback address for you. not IP, IPv6 addresses. 2AOF B240 1009. That's you. Oh, no advertise. Yeah. So you're 9. You're going to be, what are you going to be? You're going to be 5. Should I make him 5? You're going to be 8. Interface hello. What was the command to do? Passive. IPv6 OSPF6 passive. Who the hell thought an exclamation point made sense? Restart FRR. And VTYSH. Show IPv6 OSPF6 neighbors. Going to disable you and re-enable you. And we're going to say interface hello is going to be type passive. Okay. So you came up, IP show, what are my options? Show route. So you have my own route, we have my own loopback, ::9. I guess I'm getting all of these from Mikrotik, shouldn't I? So show redistribute is what I'm sending. Oh, I'm not sending anything. I should redistribute connected. I think that one goes here. FRR is not my favorite. It works, but it's not my favorite. I guess I could just look at the routing table over here. Routing routes. Okay, so I got one coming in, and I got my own. And then I should have the 2A01, that's my own. This one came from OSPF, I think. Yeah, okay, so it's redistributing this one, but not the other one? That's weird. Sure, some FRR expert has already commented in my comment section. I hate the Cisco command format so much. So what am I doing wrong with redistribute connected? Oh, okay, that goes in a different section. Also, why does VTYSH not do this? Show... I'll just look over here in RouterOS. No, didn't get anything. Okay, so I should be redistributing colon 8. Oh, there we go. They came in. They just took a little while. Okay, so that route has appeared. Now we can go on to LDP. LDP setup. I will remove the local mapping and the remote mapping. We'll leave the interface. LDP instance, new. LSR ID, ODA 9. AFI, both. Transport address. No. What's my transport address? This one. Actually, we'll use the loopback that we know, which is ::9. Okay, so you're created. MPLS, LDP interface, add Ether2. In this case, it's going to be on VLAN LAN. And I think you also need to be on VLAN LAN as well, because it's taking it on a VLAN. That's probably what my problem was before. Okay, so you're set up now. Now we go here and we set up LDP. How the fuck is LDP? There it is. Okay. Also, I mentioned this in my YouTube comment section recently. I feel like FRR is where all the people at the IETF test their protocol ideas and then commit them straight to production. And BIRD is where people that actually do routing implement the features that people actually use. Okay, do you have an example config for me? Sample configuration. Okay, let's get this straight. MPLS LDP, okay. MPLS LDP. Router ID. '8 neighbor. No password. Neighbor 2AOF B240 1000 : 9. Address family IPv6 discovery transport address 2AOF B240 1000 : 8. Interface ETH0. Why do we need exit address family when we could just use the tab? It's stupid. See if I crash it. Come on. MPLS. What is the show command? Show MPLS. Oh, show MPLS, not just MPLS. You have not discovered each other. This is very frustrating. Do I need to do neighbor? Do I need to do neighbor? Let's see. It should come on demand. LDP interface. You discovered each other. Okay, what does the comment section say? Why don't I actually need to set up neighbors? We'll enable you there. And we'll add a neighbor here as well. No neighbors yet. So your router ID and neighbor aren't showing up. I'll try TTL security disable. Sounds like a good idea. It's one of those cases where LDP is doing something kind of stupid like BGP. On this firewall, I will try this though, torch. So I'm wondering if it's one of these security problems. Read the comment section again, because you guys are usually pretty good at this. Okay, so I'm getting a small amount of traffic. Okay, 646. I'm getting packets on 646. And they're coming from... What the hell? One, two, three, four, five. We'll leave you running over there. Okay, so I'm getting the hello packets on 646, but I'm not sending them out, it seems like. Why are you invalid? Set it in Mikrotik to loopback. Does that mean this should be set to hello? Let's see. MPLS LDP interface. Okay, so we set LDP interface here. So LDP interface should be on the interface I'm using, which is SMP+2 or VLAN LAN. So under instance, I should have LSR ID and transport address, which I do. How did you guys magically come up? Yeah, so I can add Wireshark on the Proxmox node if we stop and try again. So what is my VM ID here on Proxmox? So my VM ID is 719. So I'm looking for firewall bridge 719I0. So let's go to Wireshark. try that. So I'm getting LDP hellos. Oh. That's an IPv4 packet. What the fuck? What are you doing, FRR? How about we just limit ourselves to IPv6? Okay, we're getting those as well. Oh, you're sourcing them from... Stupid. What the fuck are you doing, FRR? So you're looking for... Oh, you are sourcing them from : : 1. Yeah, okay. So you're using your : : 1 as a source address. That's dumb. That makes sense. Why nothing works. Okay, so why are you doing that? IPv6 address. You have an address on VLAN LAN. It is a good one, I think. Not advertising it, but you shouldn't be. You're on VLAN LAN. Okay. Your transport address should be 2AOF B240 1000 : 9. Somehow that was lost in translation. To restart, capture. Why are you trying to sudo? I told you not to sudo. So OSPF is making it through. LDP, okay. So you're still sourcing LDP from, stop it, from the wrong address. So your source address is : : 1. No wonder why it doesn't work. Okay. But why? Try removing you. You have a transport address. You should be happy with that. You have an LDP interface, which also has a transport address, which shouldn't need it. When's my next LDP come up? Okay, remove interface. New interface. Interface VLAN. That's it. So now the neighborship should come up and be happy. So OSPF packet has come. I'm not getting any at all LDP. I was getting LDP earlier. So this is 96, which I think is... Who is 96? Are you 96? Not you. Not you. Are you 96? You are 96. Okay, so you're the one doing V4. And then you gave up on V6 at some point in time. Okay, so I seem to be having a V6 bug in Mikrotik. So I guess we'll use 96. And I guess you'll be 97. So you're going to be 97. What's your loopback going to be? Your loopback will be 240.0.0.9. And your loopback over here will be 240.0.0.8. Okay, IP OSPF. Okay, so now I need to restart. And now you are going to use, you need an OSPF instance on version 2, router ID 240.0.9, and an area. And interface template. Area 2 for interface low. And another one in area 2 for interface VLAN LAN. And your neighborship should come up soon. Oh, OSPF is not running. Why are you so stupid, FRR? Why do you need 60 billion daemons? Okay. Now you should come up finally. Come on. Come on. There you go. You're happy. And so that means that I should now have IP routes to, well, I have that route. We should get a route at some point. LDP address family, I think, can still be both. Let's exit. So here in FRR, so the neighborship, I still need a transport address for v6. So I should be able to do so something like that should work. So now we come back here. I guess we'll restart the capture. Oh, fuck you. Why do you keep trying to sudo? I told you not to sudo. Okay, so OSPF is coming up. And LDP is coming up. Maybe. So you're sending LDP hellos. But FRR is not getting them. What is FRR doing? It should be 240. MPLS, LDP. I change you. So 240.9. Change you as well. Okay, so are you coming up finally? OSPF looks happy. LDP is still just sending hello messages. So LDP, we're sending a v4 multicast, 2 ports 646. v4 transport address of 240.9. Have they actually exchanged those routes yet? Do you actually have a route to that? You do, okay. You can ping it, okay, good. How about you? Do you have a route back? No, why don't you have a route back? So if I go here, I have no route back. Okay, that's a problem. IP OSPF passive. Just to reconnect it. What is wrong with you? So that is on LO. Check the comments section, see if you guys have new help. Okay, someone said I had a typo. Thanks for that. Interface. Okay, where was my typo here? Interface. Yep. Oops. Typed it wrong again. Let's see if it comes up this time. Also, your route is not coming up here, 2.8. Which is a different problem. So routing OSPF neighbors. So your router ID has come. You're connected. So your .8 route has not come in yet. Why is that causing me problems? So LDP is still saying hello over and over and over. Okay, anyone here have a comment? I was not expecting to be doing config file editing today on this VPS. Exit address. Yeah, okay. I was not expecting to have to do config file work to get LDP to work, like I am now. So that's why I didn't log in over VS Code. Let's see if our adjacency has come up. You are still not coming up from OSPF, which is not good. Why are you not coming up to OSPF? Did I spell something wrong or something? Interface low, IP OSPF passive. So I got your route, but you're not getting mine. Oh yes, so why is FR being stupid here? I could try between two microtics because it's being a huge pain. So I guess that's where this guy comes in. Let's see if he's happy with me. I'm going to pull this out, which shouldn't disconnect me. Pull the optic out. Let's see how this works. So let's see if you can run a gigabit. Okay, so you're connected there. New inbox. We should find a neighbor for you. Also, let's see if this guy negotiated gigabit correctly. SFP. What have you selected? No link. Okay. If I found you. Yes, I have. You have no password, I think. Yeah. Remove config. There we go. Bridge. New bridge. And bridge. Add ports to the bridge. Yeah, Ether 1, Ether 2, Ether 3, Ether 4. Come on. Oh, that's the one I'm talking to it on. Yeah, it's going to break it, isn't it? So you still have no link. You're about to crash. There we go. You're going to get a new IP address because you... Okay. Yeah, okay. So bridge... 1, 2, 3, 4, 5, and SFP. Meanwhile, how is interfaces SFP? What are you negotiating? You have no link. You need to run at, so we're gonna pick 1G base X for you, and also for you. 1G base X. Okay, so you're happy. Okay, so now I've got 1 gig fiber to this Mikrotik. Now I need addresses. So you're going to be... Oh no, you're the wrong one. I want this winbox. Addresses. 98. And I want to do bridge VLAN filtering, so I probably should do that now before I break everything. So that means I interface new... Yeah, shut up. Interface new VLAN LAN on bridge. And IP addresses is also going to be on VLAN LAN. And you're going to get 240.0.0.10. And an IPv6, you're going to get the address. What address do you have? advertise. Okay, and loop back. Okay, so now OSPF, routing, OSPF, new instance. We use version 2 this time. Interface, templates. I need an area as well. And also one on LO. That is passive. Okay, so now IP routes should start coming up. Neighbors should start coming up. Okay, what are you doing? VLAN LAN. Oh, over here I changed your port VLAN ID, I think. And you're going to be back to 1. So now you should come up. Maybe I'll plug you back in. Okay. How is the comment section now? Yeah, I don't think user experience is something any of the FR developers care about. And it drives me crazy. Interfaces, bridge, ports. Okay, so you guys have access to port 1. Can I torch you? Tools, torch. So 96 and 97 are both shouting OSPF. Why are you not? You're up, right? I think okay. I'm not sending anything. Seems oddly low that this is so low. We'll try you over Ethernet instead of over fiber because you don't seem to like that. Being forced to 1 gig. So we'll set you back to auto negotiate. I'll set you back to auto negotiate. So now you're on Ether 1, which has a different port VLAN ID. And you're on VLAN 1. And I guess I don't need to worry about taking this down because it's going to fail. Okay, so now OSPF should come up. And it did. We have both of you guys coming up. So now my v4 route should come up. I have 240/9 and myself, but I didn't get him from FRR. So FRR is being stupid, for the record. So now let's try LDP. MPLS. Okay. New instance. LSRID 240.0.10. Transport address. Should I do the v6 or the v4 here? This is for LDP. What do I have here for LDP? Yeah. So LDP interface, add on VLAN LAN, and MPLS interface, add on VLAN LAN. So now you found each other. FRR was dumb the whole time. Okay, I spent like an hour dicking around with FRR because it's stupid. So now can I do this over v6? So now so you have v4 and v6 up. You need v6 OSPF to come up. So make a new instance that's version 3, router ID 240.0.0.10. Interface template. I need a new area first. You're going to be on area 2, and interface is VLAN LAN. And on LO, area 2, passive. So v6 routes should come up. So you guys okay, so you have established neighborships now with your v6 peers. And you should have exchanged routes with them as well. Yeah, so someone advertised their loopback. So : 8, 9, and 10. Okay, that's good. So OSPF v6 is up now. So now back to LDP. Your address is still going to be that. Now your transport's going to be 2AOF B240 1010. So your neighborship was lost. So now go over here and change your transport address to AOF B240 1009. Okay, well you brought up v4. I think I need to set AFI to v4 and v6 here in the instance. Otherwise the default's to v4 only. But now, yeah, that looks pretty good. So now what I'm going to do, okay, so Mikrotik is doing way better at this than FRR was. Gotta hit FRR like every time I use it. What happened to my external displays? They are in America and I'm in Finland. I should go check some comments now that I got this to work. Oh my god. Get out of here, Wireshark. Okay, somehow I lost connection. Oh, I lost connection to the chat. Just unplug you there. Come back. Please come back. I lost connection to the internet because I lost my default route because it's trying to get it from this router now, which is complicated. So, coming back to the chat, okay, so it seems like there's no actual bugs in RouterOS. Between two RouterOS instances, everything works fine, v4, v6. FRR, I don't know what's going on. I can't get it to work either v4 or v6. So FRR being dumb. Also, FRR is not even advertising as loopback over OSPF v4 or OSPF v2. Not sure why it's being stupid. What happened to my displays? I have a display over there. I just bought it today. I paid like 89 euros for the cheapest 1080p monitor I could get. But yeah, I don't have any other monitors now because I left them in the US. I thought it'd be cheaper to buy new ones here than to bring them. They were a few years old anyway, so I bought a new display. What's the plan after LDP? Let me look at what I got on my plan. The plan after LDP is a pseudowire. RouterOS to RouterOS. I probably should add a third router in as well, because currently I just have two. And so I'm wondering if I should get out another Mikrotik to set up a third router. So I was hoping to have like a PE, so I have like an NCAP, a route, and a DCAP. But maybe I'll just do NCAP, DCAP, and not have the one in the middle. So after that, pseudowire. And then I was going to do BGP-Signaled MPLS, which would require FRR, but FRR is being retarded today, so we're not going to do FRR things. And then the last one was SR-MPLS, so we might try that now that we have adjacencies working. In a static way, not the proper SR-MPLS way. Let's see how things going here. Someone messaged me they can't see my screen. Sorry about that. Time to move the FRR config. Yeah, Bird seems to actually be really good at like everything that it does. It doesn't have nearly as many protocols or features as FRR, but again, FRR feels like it was written by the guys that were like throwing ideas at the wall in the IETF, and they wrote all of their drafts into FRR and committed them upstream, and everyone was just like, sure, whatever, we'll just take whatever wild features you have. Like, that's how we have OpenFabric. It's written by one guy in the IETF who had this idea on how to make ISIS different. And so he wrote OpenFabric, and it's just, Fabric D is just a different way to compile ISIS-D that has different path selection rules. So anyway, now that we got this to work, let's actually forward traffic between these two routers. So to do that, I need a network between them. So they're on my LAN, and they're going to stay on my LAN, and my Wi-Fi on my laptop's going to stay on my LAN. So then I need to add a new subnet for my VM, so my VM can be one end of the tunnel, and a new subnet for my Ethernet adapter, so this can be the other end of the tunnel. So I'll use 2001 DB8, or I'll use my own prefixes or something, and I'll route that across between these two routers that are using my normal home lab LAN as their interconnection. So if I go over to the graphic, so we need, this one goes away, all of this goes away. So this one will be switch 4, that's the one I have, oops. And this one will be the hex, and then we will get a, we'll get a laptop out here, so this will be hooked up to the hex. And they will be on a subnet, any subnet. So these guys will be 2001 DB8. 69, and then the server will be over here, and this will be on a different subnet. It will be on six 7. And this is also going to be on VLAN 20. So because I need to trunk it to Proxmox, I'm going to put it on VLAN 20. And then this guy will just be chilling. So let's get, oh, nope, don't save. So let's get this set up now. So this will be doing MPLS across my LAN. And then these two will be dedicated layer 3 subnets. How's that sound? Don't save. Damn, I spent like a whole hour trying to get FRR to work. FRR is stupid. I'm going to shut you down. Network, we're going to set to VLAN 20. And restart. And then over here, we're going to say IPv6 address. We're going to do new address. 2001 DB867. And you're going to be on customer com, which is VLAN 20. Oh, you've already : 1. Okay, whatever. Oops. Okay, so now if I come over here, you should have an address. Are you doing Slack? Supported method auto. What the hell is wrong with you? Proxysnet conf all except RA. Did I type it wrong? Proxysnet IPv6 conf all except RA. Okay, so you should be accepting RAs now on ETH0, and we'll come back to you later. Meanwhile, what are you doing here? Okay, so we're going to connect you over Wi-Fi. We're going to, let's see, I'm going to take Ether. Well, I know I'm kind of stuck with that. We'll make a new VLAN interface. It's going to be VLAN users. VLAN ID is going to be 2. Now, a parent needs to be bridge. Okay, and then I'm going to change port number 4. Not interface. Bridge port. Either 4. VLAN 2. Okay, so my laptop's now going to be on VLAN 2. I'll plug my laptop Ethernet back in. Then we'll add the address for that, which is going to be 2001 DB869/64 on VLAN LAN on VLAN IDs 20 to 30. Tagged on SFP+2. There you go. And you got an address. You got 2 of them, actually. Interesting choice. Why are you still advertising the old one? Okay, we're stuck with the old one, but whatever. So now you have a route here. So now if I go back to MPLS, does it have a routing table? Okay, so now I got to read more of the documentation. LDP, okay, so now we should have Trying to make you passive or something. If I put you on VLAN LAN, not VLAN LAN, VLAN users. So you're not getting an advertised path. These are all advertised by me. You're both getting implicit nulls. Why is that? And then you, remote mapping, which one are you? Switch 4. So you are owning 69. Do I actually exchange the routes themselves over OSPF as well? I think I do. So OSPF, so LO and VLAN users are going to be passive. And on this router we will have OSPF LO and VLAN customer com. Okay, so now the route should come. So you're dynamic. Your OSPF, okay. So now is MPLS finding routes? No, not exactly. Okay, let's see what the comment section says. Match the VRF, okay. So you should be in the same VRF. So this one is the hex. Which area are we in? Okay, which instance? So instance 2 is the v6 instance. So then area 2 needs to distribute VLAN users. Oops, IPv6 routes. That looks right. So how about MPLS now? Why are you guys not figuring yourselves out? Why do you not have okay, so your v4 route came in. That's positive. But not your v6. So why did your v6 not come in? So you're on custcom, I think. (64.0.0). Okay, 64.0.0. That one has an X top. Okay. So why are you not doing the same for your v6 routes? So I could just create static routes, or I could do BGP. So BGP, new instance. No, we won't do BGP today. So why are you guys stuck at inactive? That is the question now. I don't really care how the routes got there. They should come from BGP, but I don't want to set up BGP right now. I have a new approach. I'm going to ignore this and set up a pseudowire. Which means IP, ND, nope, not you. I need to remove my address on... Actually, we'll leave the 6.7 one being advertised. So I'll come here and I'll remove my address here, the 6.9, that was coming to my laptop. And then we'll add MPLS, VPLS, remote peer, 240.0.0.9, VPLS ID 6.7. What is your valid option? Optional RD. Okay. So you're going to be on bridge. You're going to be on port VLAN ID 2. Be raw Ethernet. Well, let's just leave your default. Okay. So now I come over here, MPLS, VPLS. And you're going to be 240.0.0.10, 69:69. You're going to be attached to the bridge on port VLAN 20. Okay. Do you work? I guess let's see. Run a torch on VLAN LAN for MAC protocol of, what is the protocol again? 8847. Okay, so which one am I on? I'm on CRS 305. Now I need a terminal. Okay, so you're EN14. Okay, so that should have sent something, and we got nothing. Might have to remove, well, we'll see how this goes. Is there like a status of this guy? Okay, so where the hell is VPLS? Traffic engineering? Interface VPLS. Okay. That's what got created there. So now I got a bridge. I should see port 20 tagged on the bridge. And VPLS is on VLAN 20. That makes sense. Port status inactive. Why are you inactive? Well, I guess I'll read the docs. default, the interface is disabled. What the hell? No, it's not disabled. Okay. Monitor. So I'm on the hex, taking label 20. Next top has been solved. Interface VLAN LAN, label implicit null. So you have label 20. How about you, MPLS? Aren't you supposed to be adding another label? Check the comment section. Okay. Okay, they said I needed targeting enabled. What was the exact comment I got here? Targeted LDP. Add neighbor manually with send targeted enabled. Okay. MPLS, local mapping, new LDP neighbor. I say send targeted here? No. Okay. Okay, so you're targeted, and I need to do the same for your v6. Send targeted, yes. Okay. So you're both targeted. Now, here you need to be targeted as well. Okay. So now if I go to VPLS, I should be able to put in the v6 address here, remote peer. And same over here, VPLS. And in the terminal, not that terminal. What was the command I was looking for? Monitor. Okay, so you have a local label and a remote label. That's cool. Now if I go to torch, tools, torch. Maybe this one. 8857, I think. 8847. I'll look it up again. $8847. Oh, that should be 8847, not 46. Okay, I have packets. I wish I could Wireshark them. But I'm not sure. Wireshark. Okay, got a v4 address. I do have a v4 address. Okay, filter. VLAN LAN. Okay, start. How are you doing? Okay, I've got you set up wrong. Let's try again. TZSP. Okay. That doesn't look quite right. Let's see what I get, first of all. That's not very helpful. Thanks. Which one was I? This one was the one I was streaming on. Okay, so in theory, if I just send a ping, I should get it to show up in the packet capture. Even if it's not what I wanted, that should just show up here. So we'll download that. What did you get here? Spelled it wrong, of course. Why am I getting spanning tree? I thought I was looking for only MPLS. Well, I guess I should just filter in everything. Cap. It's all Mac Telnet. Great. Oh, I have a size limit. I'll check the comment section. I wish I had a third computer to test with, so I could plug it into the network and see the packets flowing between the two MikroTiks. But in any case, I think I'll just assign some static IPs in the tunnel. how to ifconfig, I will do it in settings. Network, USB LAN. Oh, I already have a, let's use FE80s. So you're FE80, that guy. And somewhere over here, I should have that. Nothing is going across. Okay. So why not? There's no remote status for you. You seem pretty happy. Logo label 20, remote label 18. Okay, so you have a VPLS route. How about you? You do not have a VPLS route. Why do you not? You're an older version. Maybe I should update you. Let's see. System, packages, check for updates. I think this might require IPv... No, I have IPv4. Try DNS. I have no default route. Did I break it? Did you crash? Turned off. What the hell happened to you? Huh. Come back, please. Did I break it? I'll take the optic out because that might be Drawing too much power. So it's booting up, and then I guess it's up. Yep, I rebooted. That's weird. So this was on version 7.20, and the other one's on version 7.21. And I noticed the forwarding table tab didn't show up on this one. So it seems like a weird quirk. Yeah, you broke again. It is possible this broke. I have dropped it hard enough that the PCB fell out of the case at one point in the history. Oh, I wonder if it's shorting out on the SD card. There's an SD card slot on these things, and when it fell from quite a height, the SD card connector came off the board. Huh. Now I've done it. I didn't tell it to flash, so I told it to check for updates. And then it lost connection. Huh. Well, I'm not running to install on macOS. Guess I get the other one. Nope, not you. You're the wrong other one. This one. So, to replace my hEX-S, I have the HAP AXS, which is sort of like this plus Wi-Fi. And I got this because I thought Wi-Fi would be useful, because I don't know, I thought Wi-Fi would be useful. So let's hook this guy up. I thought it'd be useful as like setting up a basic access point for testing stuff, I guess. So that's why I picked the HAP, even though it's twice as big. Oh, I need your password, which is written on a sticker. Not that sticker. This sticker. Okay. I'm booting up. The other one I have, by the way, is a HAP AX2. This guy is going in our summer cabin. Do I have the other thing to show you guys? Yeah, I'll show. Well, this thing boots up, I'll show you my other cool stuff. Not in there. Where did I put the box? Did I lose the box already? I lost the box already. I'll find it, don't worry. So I got a Mikrotik, I think it's called the SXTR or something like that. It's the high gain LTE modem. So I talked to them a bit about it. They have a newer version that does 5G with 4x4 MIMO. But in the land of summer cabins in Finland, we don't have 5G, we have 4G. Because we need to run at 800 megahertz because of all the trees. So it's a 2x2 MIMO LTE radio with a high gain antenna, and I'm going to mount it on the side of a tree because currently our summer cabin gets about 5 megabits per second, which is fine for checking email and stuff, but is not enough to watch Netflix, and that's a problem. So We're going to get the HAP AX2 in the cabin and the 4G radio outside of the cabin, and hopefully bring ourselves up to like 20 megabits maybe. Okay, so this guy has shown up. He's running a newer version. And I have to type in the password because it's a unique password. I definitely got you right. Come on. Come on, come on. Oh no, what am I doing wrong? This is the one, isn't it? I think I reset this before. HAP BA3. So I got this before the HAP BA3 came out. So I got the AX2 for the summer cabin. The BE3, I will probably ask them for a review unit. I have a big ass radio from Omada up there. It's like their flagship with 10 gig Ethernet and stuff. So that's fun. That one I still have to test. I have some Halo stuff I need to test for Wi-Fi. I'm a bit behind on testing stuff. I've got a really big video coming out this upcoming week, which has taken an enormous amount of my time to do stuff. Did I change the password to be blank? Did I change the password to be admin? Oh well, I'll factory reset it. I pretty much factory reset these things like every time I use them. Not gonna lie. Let's see if that works. So this one I got for testing. I didn't plan on using this for production stuff. I wanted the SFP port because I like doing stuff with fiber, and that's why I picked this one as a replacement for this guy. So that's one of the things I do love very much. This one is twice as big, which is a bit unfortunate, but I guess that's fine for me. Come on. Yeah, thread support. I'm interested to see how thread goes for them. I love thread. I wonder how they are going to implement it. QV3. Oh my god, connect. Oh, I wonder if... Yeah, there we go, okay. Was not me, it was macOS. So when you connect by MAC address, it sends a broadcast packet, but because I'm on a secondary Ethernet interface, it sends it to the interface with the default route. So I have just gotten rid of the config. I have no config, so I need a bridge. I also, oh, you guys lost my screen. I'll get it back for you in a second. And all the ports to the bridge. Port 1, port 2, port 3, oops. Okay. Now Wi-Fi is back on. Now I should be able to connect by V6 link local address, I think. We'll see, I guess. How do I have the wrong... Oh, there's no password, okay. So when I told it to remove the config, I guess it removed the default password too. Ether 4, Ether 5, and SFP. Okay, let's see if we can remember the settings, the steps we did before. So bridge, enable VLAN filtering, and then I'm going to set my user port. Yep, I lost it. Anyway, I'll plug you into port 1, unplug you. Now I should be able to connect over Wi-Fi. And then when that comes back up, yes, I can set the bridge port 4 to be on VLAN 2. Okay, so now we'll plug that into port 4. Now I need to bring up the OSPF adjacency, so I need an address. So I need an address on... Come on, what's wrong with you? On this network. And it's going to be 11.64, no advertise on... I need a bridge VLAN interface. VLAN LAN on bridge. I need a cust interface, so we're going to do VLAN cust VLAN 2 on bridge. You need to be on VLAN LAN. And then I need loopback to AOF B240 1000.11. On loopback. Okay, now we need OSPF adjacencies. Routing OSPF. Instance version 3 240.0.11. Go. Areas. Go. Interface templates. VLAN LAN. Let's go. Okay, have you found neighbors? What is wrong with you? Oh, there we go. Okay, you found your neighbor. Have you exchanged routes yet? Not exactly. Maybe yes. Yes, okay, we found you. It's your ::9. MPLS, we can add LDP. New instance. .11. AFI is both. Transport address. Okay. LDP interface templates. Interface VLAN LAN. Okay, so now neighborship should show up. Yes. Need to enable MPLS processing on the LAN interface. You need to become static. Interface 9 is going to be targeted. You got a lot of interfaces there. Okay, so you're up. So next up on this side, I need to add a new neighborship for 11. you should come up. Okay, so you're happy. So now you have a forwarding table with nothing in it. And you should have a forwarding table with nothing in it. A little bit more than that, okay. Now let's add our VPLS. New VPLS 1. Nine. On bridge, PVID 2. Okay, you are happy. So you have not appeared in the forwarding table yet. Now to you, MPLS, VPLS. Your neighborship has changed to 11. Do you have a remote label? Not yet. Okay, what is the comment section like now? No, we did not switch to OSPF. We need OSPF to work for LDP to work, for MPLS to work. Okay. Remote label 18, local label 18. So you appear to be up. And you appear to be up as well. It says it's running. So I'm going to make sure that I actually don't have any addresses on that interface, VLAN custom, at least not v6. So now if I go here and I do IPA, so I got this guy on ETH0. Actually, it's easier if I do it the other way. EN14. U. No, we do not have a pseudowire. 199 is sending back destination. Okay, so it's failing to ARP, which does not that much surprise me. So let us run torch on VLAN cust and see what happens. You're not coming in at all? Someone's sending a bunch of DHCP queries, which makes sense. Oh, this was the laptop side. I should try a torch on this side. Not radius, torch. So we're trying on VLAN custom for anything. And what are we getting? We are getting FFO2. That's a weird one. Oh, it's probing for, that's an RA. Are you actually in the right VLAN? So VPLS 1 is in VLAN 20. VLAN 20 is allowed on Does it not like that I have a VLAN on the bridge? Let's change you to be 30. So we have no interface on the bridge. Are you back up? Hopefully. That means in Proxmox I have to change you as well. I'm not sure how to torch you. I'm going to have this guy do a packet capture on interface VLAN to LAN. Oh, do I need to undo bridge hardware offload on that VLAN? No, I assume it would handle it correctly. Okay, so we'll stop the capture, download the file, open the file, it has nothing in it. How do you have nothing in it? Okay, what if we capture on the VPLS? Still have no files. Guys have any input? So the VPLS tunnel thinks it is up, but I don't have okay, so you are up. You have no prefix, you are label 18. And over here, you are, again, have a VPLS that is happy. Okay, so the HAP says it's receiving traffic, but it's not sending any. And this guy over here says he's receiving traffic, or he's sending traffic. but not receiving any. So we're having a problem going from the HAP to the CRS. So why is that? Maybe I am not supposed to have you. Well, that's a nice warning. But whatever. Now we lost it. So you liked it better when you had a VLAN interface on that same bridge. Oh, no, I deleted the wrong one. Should have deleted you. Okay, so hopefully I can recover from all that breakage. So you're up. You're invalid. Great. How about OSPF? Has that found itself again? No, okay, so I broke you. Okay, you should come back up in a few seconds. There you go. You're also broken. Should come back up. Okay, so you're up again. We are now once again receiving traffic, but not sending. Why are we not sending anything on the HAP? So VLAN filtering enabled. Port switch CPU is 2, VLAN on bridge 1, PBID 2 VPLS. Makes sense. I'm on port 4, right? 1, 2, 3, 4. What do I have MTU set here? MTU 1504. Could not set MTU. Why not? What's wrong with you? What are you tied to? You want me to change all these guys to 1504? Say 1508. Whatever, I'll deal with you later. What is my comment section telling me? I'm hoping for a 1500 MTU on the bridge. I guess the problem is I use the bridge for the underlay and also the overlay, which is not ideal. So if I set U to a lower MTU of like because I use the same bridge for the... Okay, what if I take the port out of the bridge and make a new bridge? Bridge 2. With an MTU, I'm going to lose some, say 1460. I'm going to move port... This is complicated. I'll just leave you as is. Dealing with the MTU issues. Whatever. So you're still receiving traffic, and you are... So either 4 is sending... We're sending out either 4. Okay, so that means we're getting the labels over VPLS. Why are they not? Okay, Wireshark. Wireshark. On EN14. Spanning tree. Okay, so we're sending spanning tree. So what bridge are we? We are 04F41C. Which bridge is that? For FR1C. Okay. So DHCP Discover is going to be my MacBook. Okay, so none of this is actually going over MPLS. It's just traffic on the interface. How about on this guy? Yeah, so I know MTU is a problem, and I'll have to deal with that later. But a ping is not going to be that big, and I just want that to work now. The other problem I'm having is that I can't set the MTU on the bridge larger than the smallest member. And because I'm using different VLANs on the bridge for my underlying interfaces versus my not underlying interfaces, it's a bit harder. Especially because on the one in the closet, I'm using my underlay on the same bridge as my overlay, which means the overlay members will have a lower MTU. Which probably means, well, I don't want to take port 2 out of the bridge because I use the underlay and the overlay on the same I will think about it. So So why are you not working? So you are showing up as transmitting. I'll run TCP dump on your side. All right, you install TCP dump. Okay, so I'll switch you back to no VLAN for a bit. TCP dump. Okay, and I'll switch you back to VLAN 30. Okay, listening on ETH0. So I'm not even seeing spanning tree on this side. Empty packets dropped by kernel. That could be spanning tree. Thinking how I could set this up better. Or do I go to bed and do it later? This has been much harder than I expected. Mostly because of FRR, but ignoring FRR, it's been much harder than I expected. I'll read comments. I lost connection to the chat. I gotta read them here. STP spanning tree could be filtered on Proxmox. That is true. It shouldn't be, but let's see. So let's have IPv. Well, add an interface first. VLAN pseudowire, VLAN ID 30 off of bridge. Yes, I know. So now I should have a v6 address that came up on that interface, which is this one. So now can I ping that from here? Oh, now suddenly I have a whole bunch of neighbor solicitations. Okay, so I can ping across my VLAN 30 from the virtual machine in Proxmox to the CRS. So that's the first hop. So now if I go here and I again create an interface, we're going to call it VLAN pseudowire on VLAN 2 on this side. Then it should again have a v6 link local address, which is this one. So we'll ping that, and I need a sudo ping 6 because macOS is weird. On EN14. Okay, that's not working. Now it is working. Okay. What is taking so long? That's weird. Okay, so that ping works. So next step, can I ping the pseudowire address on the HAP from the VM? No. Okay, so that's not working. Why not? Next question. Bridge. Can I look at the bridge forwarding database? So what is your MAC address? Your MAC address is BC2411. Something with BC2411. There's a lot of them. BC2411 020199. You're showing up on Ether 1. Why you're showing up on Ether 1? You're supposed to be on... That's not right. So I wanted to do this with Linux so I could run TCP dump. Which would have been very nice right now to have TCP dump. Can I have a span port on a bridge? Port mirror. This looks like a very old post. 2022, okay. Interface Ethernet. Oh, fuck off. What the hell did I do now? Interface Ethernet switch. Don't like that one either. Bridge. Maybe the comment section told me how to add a port mirror by now. Switch rules. Okay, switch. I want to take Ether 2. Switch rule. Why can't I pick Ether 1? Is Ether 1 not on the... Oh my god, is that my problem the whole time? 1, 2, 3, 4. What's wrong with you? Forwarding, yes. Okay, you're forwarding. Root port, edge port, point-to-point port, yes. Actual path, okay. So you've become my spanning tree, but you're not hardware offloaded. What if I just turn off bridge hardware offloading entirely? So you weren't hardware offloaded, is that because you... I don't know. That's weird. Oh, I can't add a switch rule if you're not hardware offloaded. That's my problem. 2, 3, 4, yeah, okay. Oh, because on this model you don't hardware offload? Is that it? If I move you over to port 2, then you'll hardware offload, I bet. I think port 1 on this model is connected straight to the CPU. So that is affecting things. So switch, rule, new rule, port, Ether 2. That is my Action. Mirror. New dest port. Ether 3. Not supported for this switch. Oh, fuck you. Okay. No switch rules for you. I can do that on the CRS though. Switch rule. Switch 1. If you are on port Ether 1, action mirror to SFP plus 3. That is my 10 gig. Let's plug that in, which means I have to unplug. Probably also should turn off that from being a bridge member. I'm going to delete you from bridge ports so that you're not going to also do networking. You're just going to do port forwarding. New Wireshark. And we're going to capture on EN20. You better show me stuff. You're on 3, right? Yeah, SFP plus 3. Interfaces, SFP plus 3. Should be having traffic egressing now. And you do, okay, so does it show up here? So why is OSPF not showing up here? Switch rule match. So the ingress interface would be CPU interface. We'll mirror you out there. Switch 1 CPU not supported. Okay, so I can't mirror ports. I can't mirror traffic that came out of the CPU, just traffic that goes into the interface. That should be fine. I should still be getting LDP. So Cisco Discovery Protocol says I'm on SFP plus 3. Not helpful. You, what did you do? What happened to you? Did you disappear? No, you're still there. How did I lose you? I broke something. Somehow the switch rule broke that connection. So how do I set mirror now? Mirror yes. Port mirroring. Okay, so you just said mirror target somewhere else. Switch settings. Mirror target SFP plus 3. Okay. Now I should have mirror traffic coming in Wireshark. And I do. LDP is happy. Okay. So now if I do a ping on EN14, nothing happens. Nothing at all. How about you? What if I ping you? So I'm receiving the LDP stuff, and I'm seeing the OSPF, but I'm just not seeing any MPLS packets. So you all told me what I already figured out, that Ether1 is not on the switch chip on this guy. Should be able to connect now. Okay, so we fixed you. Given that information, can I create a switch rule that says mirror on switch 1 port Ether2? Okay, no I can't. No rules I can create on this switch chip. What am I doing wrong here? So you're seeing traffic. Can I tell the ping to go faster? Well, I guess 1 second's enough. Should I make a new bridge for VPLS? So over here, I know Ether1's not on the bridge. So make a new bridge, PW bridge, 1488. I think that gives me room for 3 headers. Give ourselves a little more space. No VLAN enabled on this bridge, and then I'm going to move port 1 to the other bridge, and then I'm going to move the VPLS also to the pseudowire bridge. Since port 1 isn't on the bridge anyway, I'll move you over here. Where's that config? MPLS, VPLS, you. You're going to go to pseudowire bridge. So now bridge can have an MTU of, we're going to set you guys to 1508. Oh, fuck. So we're going to leave you guys at 1500. Gonna drop me now, I bet. Oh no, not quite. Okay. So okay, so you guys are all happy now. The VPLS is going to get a MTU of layer 2 MTU of 1588, I think. Should calculate my MTU for me. Sorry, 1488. 1560, 20 bytes should be enough. So I'll set you to 1468. How did you get to be 1568? Okay, so that side is now on its own bridge. So now suddenly traffic is flowing. So over here, I'm going to take you, oh god, I got MacTelnet. Wireshark. On EN14. Still just spanning tree, okay. Not the best. Now I'm going to do the same on the CRS. So on the CRS, we're going to make a new bridge. Pseudowire bridge. And we're going to make a new interface, which is going to be VLAN pseudowire. Its parent is going to be bridge, VLAN ID 30. Actually, I already have one, don't I? Yeah, okay. So your N2 is going to be 1468. Then, in Pseudowire bridge, I'm going to add a new bridge port that is VLAN pseudowire to bridge, pseudowire bridge. And then I want to move the VPLS there too. So I'm guessing it doesn't like being on the same bridge. Okay. Oh, no, traffic shot up. Okay, that's a... I'm pretty sure all of these... Oh, I got an OSPF packet. Where did you come from? Oh, you came from FRR, which I didn't stop. There we go. We got it. Yay! Okay, so the problem was I had a bridge on both of these guys, which was my hardware offload bridge, and I was using different VLAN IDs for my VPLS services. What I should have done was create a VLAN interface on the hardware offload bridge, bridge that to a non-hardware offload bridge, which becomes the customer bridge, and then bridge the VPLS to that. So it did not like when I was using the same bridge with different VLAN IDs for VPLS and for the underlay. Which makes sense. But it's irritating that it didn't warn me, or I don't know what I expected it to, but irritating. So that's done now, and I am, gosh, 4 hours into this thing? Holy hell. So I wasted like an hour on that, and I wasted at least an hour on FRR. Probably more than an hour on this. Okay, what else? You have to set the US port. Okay, so yeah, so I did all that. The default is raw Ethernet. Yeah, so I removed that because I thought the default was fine. How frustrating. So I can go back now and get rid of the port mirroring config I did on the CRS. The switch rule. I get rid of the switch settings. Mirror target. I'm going to put the guy back in the bridge where he belongs. I said P+3 belongs in the bridge. Yeah, okay. So, seem to have figured that one out now. What else was I thinking? I wanted to do SR-MPLS, but I think I am probably done for the night. So I have two things I wanted to do, BGP-Signaled MPLS and SR-MPLS. For SR-MPLS, I was just going to do it statically. My hope was that I could do some sort of static traffic engineering with specific routes getting specific label stacks, but that is not going to happen today because I have been here for 4 hours and need a break. How did the stream go? 44 people. Viewer activity. Yeah, okay. Any last questions then before I sign off? Now that I got it to work. And the problem was the stupid bridges. I guess I should do a packet capture before I'm done. So I'll get the sniffer back up again. We're going to sniff on Ether 1. Sniff on VLAN LAN. MPLS5.pcap, apply, start. Switch back over to you guys here. That's probably good enough. No bytes. Tools, sniffer. Still no bytes. Okay, what do we sniff on this guy instead? Tools, packet sniffer. Gotta pick interface, bridge. So now I should have some pings coming across because I think they're still running. Yep, they're still running. So we'll stop that. And now what is my file? MPLS6.pcap. Close Wireshark. Shut up. And we will open the PCAP. So do we have MPLS here? We do. So these packets are all in MPLS. So if I pick the ping, so we have Ethernet 2, and our encap there is VLAN, and on top of that we have VLAN ID 1, and inside of that we have MPLS label switch packet. And in there we have multi-protocol label switching, label 17. So that is our MPLS header, which is only 32 bits. Then in there we have a pseudowire control word, and then we have another Ethernet frame inside, which has a IPv6 and IP and ICMP. We did it. We got MPLS. So I think because the packet is not going through any intermediate hops, it popped the transit label. I guess it never added it. So if we were going hop to hop to hop to hop, we would have a label ID for the tunnel and then a separate label ID for the hop. But because it was a direct hop, it didn't need to add a second label. Yeah, so I didn't have a good time with FRR. Maybe FRR works well with itself, or Cisco or something like that. Yeah, so it's penultimate hop popping on the outer label, the transport label, because it only has one hop, but it still has to have the tunnel label so that it knows how to decap the tunnel at the end, which makes sense. So I'm going to sign off now. I guess I'll wave goodbye to you guys. I had a total of 13,338 almost elite number of viewers, of which there are currently 40 of you, so thanks guys. Goodbye. I think I'm going to do a live stream in about 2 weeks. I might revisit MPLS for a live stream, or I might revisit it for a video. I'm not sure. My next live stream planned, though, is going to be a multicast. And I guess I'll read off what I was planning on doing for multicast. So we'll see how far we get. But I want to do a quick overview of IPv6 multicast addresses because they're encoding information in the address for the group membership. Next up, I was going to do link local multicast, so MLD snooping, how switches, specifically this switch, handles MLD, multicast listener discovery, which is the IPv6 version of IGMP. Then I was going to set up 2 routers to do PIM SSM between them, so this would again be the one in the closet, the CRS, and the one out here. And then across that I was going to send video from a VM, streaming some video, which then gets sent through the routed network over PIM to the link local network, which is just the client plugged into this, to view that. And then the last thing I was going to do is back to unicast, a technique called MABR, multicast adaptive bitrate. So that's what I'm tentatively thinking about doing for a live stream. Lock the focus next time. I think the focus is locked. It just might be off. I don't think the focus is on autofocus. I had to set it from here while looking at the computer monitor over there, so I probably just got it off a bit. Yeah, so goodbye guys. I guess I'll end the stream.